In this video, we have a little bit of redemption with this old Sony Trinitron TV that I found at eWaste. It's almost the same one as a different one that I completely restored with an LCD screen because the flyback had blown. But maybe, just maybe, I can get this one to work without having to gut the whole system. That's coming up right now on the Retro Hack Shack After Hours. Hey everybody, my name's Aaron. Welcome back to the second channel, Retro Hack Shack After Hours, and we have another eWaste Wednesday video, otherwise known as Ew. That's right, eWaste Wednesday is, Wednesday, not eWaste Wednesday, but Wednesday is the day that I go to eWaste and find things, and this was sitting out in front of eWaste today. In fact, I've been finding more and more monitors. I don't know what it is, but I've been finding more monitors than computers lately. So I've ordered some new testing gear, and I'm going to be going through a monitor marathon, probably on the next episode after this, or coming soon anyway, on this channel. We're going to be going through and testing a whole bunch of monitors, because I have a ton that I have to get through. But today we're going to be looking at this TV, not necessarily a monitor, although it would be perfect to hook up your Atari VCS/2600 to if you want to, aka the Atari, as we called it back in my day when I was a kid, because there was no other models of Atari. It was just the Atari. My first Atari I hooked up to a TV just like this one back in the late 70s, and we used to play all those fun games on it like Tank, or aka Combat, and Adventure, and all those really cool games. But some of my favorites were Yar's Revenge and Raiders of the Lost Ark, and I could go on and on about Atari, but this isn't about Atari, it's about this TV. Now, as I said in the opening, I had a TV very similar to this. In fact, they're just one minor model number apart. This is the Sony KV1214, and the model that I worked really hard to restore and was unsuccessful at was the KV1215, and that's the one that I use in my 70s set and sometimes my 80s set. I redid the whole thing with an LCD screen, and it has HDMI inputs and all kinds of stuff on the back now, and that is still working great. But this one is fresh from eWaste, still has all the guts inside, and so we're going to plug it in and see if it works in just a minute. Let's just take a quick look at what we've got here. We've got a 12-inch CRT screen. I don't see any burn-in. You wouldn't normally expect burn-in on a TV like this because it's always changing the picture. It's not hooked up to a static screen. But yeah, just from the front view here, the screen actually looks good. If that's any consolation, we'll see how this thing is working. And then we have VHF and UHF tuning knobs over here. One of the differences I can see right away from this model and the other model that I've already restored that was very similar to this is I believe the controls on that other model, the volume and all the other controls like that were over here, and the tuning dials were all the way on the right. With this one, the tuning dials are on the left part of the control section, and the volume and all the other stuff is on the right. So a little bit different on this particular model. Up here in the very top, we have something that is new to me. It's called Econo Quick. So I'm assuming that has to do with what's underneath this, which is the AFT, or automatic fine tuning. This is Aaron from the future here. Just a quick note that EconoQuick was actually Sony's way in the Trinitron series of warming up the tube or getting to a picture faster than having to keep the heater warm. This would in turn save energy because the TV wasn't constantly drawing a trickle charge to keep the tube warm so that it could actually heat up and show an image quickly. So just wanted to clarify that. Fine tuning is when you would use this knob here, you would tune into your channel, and then if it was still slightly off the frequency, you could actually use this little knob here and do fine tuning to move that so that it matched the signal precisely. Underneath that, we have the power and volume knob, and then we have the picture control. Now, one of these knobs is missing. In fact, this was down here under picture, and I actually moved that up to this position here so that I could actually test it, because when I found it, it was down here and I couldn't find a way to turn it on. So I just moved that knob up there. And then these controls under here, it looks like we have an on-off control for the automatic fine tuning, and it looks like it's missing, maybe it's not missing a sticker. I don't know. It's hard to tell. These other ones have stickers on them and this one does not. So I don't know if that had something there or if it was just a silver button. Underneath that, we have a hue control because this is a North American TV, so we have to adjust the tint, and then color underneath that. So tint, hue and color, separate controls to really get fine grain control over the color of the picture on the screen. And then underneath that, we have an earphone plug. In fact, we have two earphone plugs. This would be a mono TV because stereo TV did not exist yet at this time. I believe we're going to find that this TV was probably made somewhere around 1976 or 77. So yeah, there was no stereo broadcast TV at that point. And so these are probably two mono plugs for sharing, hooking up two set of earphones if you wanted to watch without bothering the rest of the people in the house. Now, looking at the back of the set, the first thing we notice is it does have the rabbit ears, Sony branded, by the way, rabbit ears. So these are the ones that would have come with the set. Also, there are two controls here. One is brightness and the other one is vertical positioning. Those would have been probably pretty important, probably the most common things that you would have had to adjust. I remember adjusting that vertical roll on these things that would always get out of whack, it seemed like. And then of course the brightness you would want to adjust. We have the antenna inputs for VHF and UHF over here. And there are a few other controls, picture controls down at the bottom, horizontal positioning and size, vertical size, I believe is also down here. And then way under here, it's going to be impossible to see with black on black text on black plastic down here. But there, it does look like there's RGB controls for brightness, for red, green, and blue. Exposed at least access to those with a screwdriver or a special tuning adjustment tool if you need to change those. Okay, I've got this set plugged in, and I did test this once already just to see if it was working or not, and it was not at the time. So let me go ahead and turn it on and show you what this thing is doing. Got a scratchy pot, that's one thing. And you can see there's a line there, and I'm just going to go ahead and turn that off really quick. If you saw that line, that means we have lost vertical deflection. So everything is being squinched down to that single line there, very, very bright. And so what'll happen if you leave it like that, you'll end up burning a line into the phosphor. So don't want to do that. So that could be a bad transistor, a bad vertical transistor. It could be a bad diode, could be some sort of shorted capacitor. It could be a bad solder joint. I mean, it could be a lot of different things. If you remember last time, I had a much different situation. At least this one, we're getting horizontal and not vertical. The last one I had, I just couldn't get working, and it ended up seemingly a bad flyback transformer. So hopefully in this case, we can get this one working, but that's what's happening. It's getting no vertical deflection, and it just has a line across. It could be a bad pot or something like that as well that's leaving something open. I'll fiddle with the knobs a little bit, but I think we're going to have to go ahead and break this open and do some research on the inside, which will be not very fun. It is fun and it's not fun. It's fun because there's so many components in there that can fail. It's a little bit of a puzzle. So if you like complicated puzzles, this is a great project. Of course, taking this thing apart and opening it up is going to expose us to high voltages. So don't do this if you don't know what you're doing. Not a great first project for someone who's beginning electronics. If you want to do a project like this and you've never opened up a CRT before or worked on a CRT, just know there's high voltages. Maybe grab a friend or somebody who's done this before and ask them for help so you do it safely. Knowing how to do things like discharge the CRT, staying out of harm's way of high voltage areas is going to be really helpful to make sure you don't get injured, and I certainly don't want to be responsible for that. Okay, on with the show. And before I break this apart, I just want to point out that this TV is extremely dirty. It's obviously been sitting in a shed or something in a garage. It's got water stains or who knows what kind of stains on there. I hate to think of what that might be. Yeah, it's just really, really crusty and dirty. Doesn't even really want to come up very much with my finger, so it's crusted on there. All right, so I've got the back off. Pretty simple affair. 4 or 5 screws. There's one extra one holding the antenna connections here onto the back. So I think it's 5 screws total or something. Anyway, pretty simple to get in here, but man, this thing is really cruddy inside. Let me just walk a few things, just initial observations that I have about this set. The first is just the amount of crud. And to illustrate this, this cord over here, believe it or not, is white. In fact, I think both of these are. I just bumped that one. And you can see I rubbed some of the stuff off. But before that, I just assumed these were black cords. They are not. They are white cords. So this thing is just covered in soot, and not soot because it's not related to fire, but it's just gunky crud. Probably the worst that I've actually ever seen inside of a monitor or a TV that I've ever worked on. It's surprising that this thing is actually even working at all. It's surprising that we're getting high voltage. But yeah, just look at this down here, this board here that has to do with, assume the tuner and the signal and stuff coming in. It is all completely crusty. If we look further down on the board here, all of those pots and stuff, or cans with the pots and adjustments inside, those are all like have an inch of crud and dust on them. And even the wires themselves feel a little bit crinkly. It's also got this control in the middle of the yoke here, which I've never seen before. It's turned all the way one way, which is nice. It's turned all the way counterclockwise, so I don't have to worry about getting it in the wrong position, but it does move, and I'm not really sure what that is. So TV folks, if you know what that is, please let me know. I assume there's maybe some magnets, or it's a big resistor or something that you can fine tune focus or something like that with, but it's just sitting up here on top of the yoke, and I haven't seen that before. Perhaps it's super common and I'm just inexperienced enough not to have seen it. A lot of these sets, especially when you got into the 80s, they were the main board on the bottom was attached in a very flimsy manner to the front of the set, so that, you know, I'm always kind of a little bit leery of when I move these things around that the main board is just going to snap off, the plastic's going to break or something, and then I'll have a real mess on my hands. But this one is very solid. It's got metal all around, and so there's no movement. It's almost like a IBM 5154 that was also built very solidly, but it's got, you know, metal bracing all around. It's attached to the front of the set very securely, so I have no problems moving this thing around, just being careful of high voltage, of course. Looking at this side, it's definitely a different set than the one I worked on before, because the flyback on this one is kind of in a different area, and, you know, there's this plastic shielding that wasn't on the other one. The flyback wasn't in a can on the other one. Maybe that means this is a newer set. Maybe it means it's an older set. I don't know, but they definitely got things kind of protected here pretty well, and they're still very, very dirty. I mean, you can see, just look at that. That's how much crud is on here. So, yep, it's really, really dirty. I'm going to take it off and take it outside and blow it out, and then I'll start troubleshooting, probably starting in this section. I'll take a look at the schematic and isolate that vertical signal that's coming through, and hopefully can trace that through here and find something wrong with it and fix it and get it working again. All right, well, I got all that dust out of there. I do want to talk a little bit more about safety, because as I'm discovering here, this is a two-prong non-polarized cord, which means this could be a hot chassis. This could go in either way to the plug, and so you don't know whether the chassis, which is normally ground, could be neutral or it could be hot. So I haven't done enough digging to know whether that's the case on this set, but just because I'm looking at the plug and I can tell that this is non-polarized plug that could go in the outlet either way, I'm going to be hooking this up to a isolation transformer just for safety, just to make sure that there's no problems with me, you know, if I do happen to touch the chassis and make a connection to ground somehow, that I'm not going to get electrocuted. Would not be very comfortable. So yeah, I'm going to do that. So be careful of that if you're working on these sets. Also, the plug on this is attached to the back of the outer case, the back case, but it terminates here. It's not actually soldered onto the board. It terminates in this plug, and then this is pushed through the case and it latches with these little latches. So what that means is when you put on the case, when I put the case back on, I'm going to have to be really careful to line this up so that it seats nicely with the plug on the back of the set that goes into here. But at the same time, it also makes it easy to get in and service. All right, well, I've got this connected and working, and I've got the brightness turned down as much as I can so we don't get that line across here. And I just want to test the controls up here. I think that's the brightness, which I have, yeah, that's the brightness, which I have turned down all the way. And then this one was the vertical rolling or the vertical positioning or something. So, oh, look at that. Oh, look, this TV might be working, guys. As I move this thing, it's actually getting better. That might have been all it was. I might not have even had to take this whole thing apart. Because look, I can get it almost all the way as far as it's supposed to go. Is that the only thing wrong with this as a pot? I mean, that does happen. People see, they turn it on, they see it's doing this, and they think, oh, it's broken. Sometimes it's just a dirty pot, and we saw how dirty this thing was. That's definitely having an effect. If I could go all the way this way, I'm getting what looks like a full vertical stretch there. I'm going to turn this off, disconnect it from power, clean these pots, and I will be right back. Maybe this thing is actually working. And we will be right back after I thank the sponsor of this episode, PCBWay. PCBWay offers low-cost, high-quality PCB manufacturing and a whole lot more. One of my favorite features on PCBWay's website is their project page, where the community can upload projects. You can browse these and order these particular parts so that you can use them yourself. Or you can create your own project by uploading your design and receive 10% back when someone else orders your particular project. So check out PCBWay for all your PCB manufacturing needs, and I thank them for their support of the Retro Hack Shack. All right, well, look at this. We've got a picture I'm feeding from my Commodore 64, which is in the back there, kind of hanging off the shelf right now as I was plugging in some wires. But I'm feeding the output of the Commodore 64 out through taking the composite signals, putting it through an RF modulator, and then through a balun, which is like something you can use to hook a coax cable up to antenna leads if you have an old set like this, which has the right resistance level on it and everything, and feeding that into the antenna hookups, and we've got a picture from the Commodore 64. Now, of course, if you know anything about the Commodore 64, you know that the colors aren't right. And there's also a bit of pincushion in here as well, so I'll have to see if there's a pincushion adjustment so that we can get this straightened out. And also there's looks like it's up a little too high at the top of the screen here, but basically the tube itself and the TV appears to be functioning fine. The text is pretty crisp and sharp for a TV of this era. I think this is the vertical position. No, this is the vertical size. So I can make the vertical size a little bit better. All right, well, I found some of those other controls I was looking for, like the pincushion control, and they are on the bottom of this board right here, which is accessible. If you were to tilt the TV down on its face, you can get in from the bottom without taking everything apart, and you can get to those controls. However, you wouldn't be able to see what was going on the TV at the same time that you were adjusting the controls. So what I've done is, I guess you could hang it off the table or something and get under there and twiddle those with a screwdriver, but what a pain is that? So anyway, what I've done is because Sony was really good at their construction of these TVs, by taking off a few screws, this particular board right here will pivot out, giving me access to those pots, which are on the inside of this board. So you can't get to them from this side, but if you swivel this out, you can kind of reach up under there and get them that way. So I did find those in case anyone comes across this set and is wondering where those controls are. So I've got, I believe, something to do with the vertical here. I'm not exactly sure what it is. I've got a tilt control, and I've got the pincushion, and then I've got horizontal frequency adjustment as well. So that's what I'm going to be doing next, to try to see if I can get the picture aligned a little bit better on the screen. All right, so maybe this set has more troubles than I first thought. Can we fix this set, fix the colors, fix the pin cushioning, and get everything working again? I hope so. And by the way, here's something you don't see me wear very often, these thick rubber gloves. The reason I'm wearing these again is just for safety. There are a lot of caps on these boards that could hold a charge for quite a while. If the bleeder resistors aren't working very quickly, they could hold a charge. And I've certainly become victim of this. When you're working on a board, even if you turn off the set and you go in to fiddle with something and you stick your hand on the backside of two prongs of a cap, you're going to get yourself a really pretty good shock there, because they can hold, 220 volts even on a 110 set. they can hold a couple hundred volts in them for quite a while as those capacitors drain. And it's really easy to brush up against them or short those out. And it's not very fun. And also, I'm going to have to do some close-up work in here. Still, of course, avoiding any high voltage areas. But just in case, these gloves are nice because they do come up a bit on my arms here. You can see they do come up quite a bit. So, you know, with those short little rubber gloves that you can wear that aren't very thick, you know, they're only going to cover this part of your hand. But this is actually going to cover anything that I would, you know, hopefully brush against by accident will be covered and protected. I don't wear those gloves for like cleaning. I know there's some, I kind of laugh at them, but there's some YouTubers out there that wear the murder gloves, like just, oh, I found a spider in my whatever computer, I'm going to put on the murder gloves. No, I grew up kind of out in the country on a farm, and we were out mucking around with a lot stuff that was a lot more dangerous than whatever you could find in this set growing up. Okay, lecture about safety over. So the first thing I want to do is just pull this board out a little bit. And I mentioned that there is a pot in here for Pincushion. And I just want to see if that pot is actually doing anything, because when I first looked at this, it looked like it wasn't actually doing anything. So by getting my fingers under here and moving it, yeah, I can move this pot basically all the way one direction or all the way the other direction. I don't see that moving at all. So that's telling me probably the first thing we need to do is take a look at the Pincushion circuit and see if there's maybe the potentiometer isn't making good contact or something's going on, because I'm not seeing anything. And I don't think it's the pot, because if the pot was a little scratchy, of course we would see, you know, some flickering or some changes. We're not seeing anything. So maybe there's a bad cap or something. Let's take a look at the schematic. So here's the Pincushion pot. On this side, if we go back, there is, I think, the vertical center pot is back here. So that's the vertical centering information. So something back here certainly could lead to low voltage or something like that, I suppose. But since this isn't doing anything, as long as the pot's working, and I'll test that in just a minute, the big thing I see here is this capacitor right here. So that's going to be an electrolytic capacitor. And you notice here, this is 100 volts or almost 100 volts on this transistor right here. So what that tells me is that this is going to be a 4.7 microfarad capacitor, but it's probably going to be rated for like 120 volts or something like that. And those higher voltage capacitors tend to go bad in these sets, especially if they're next to something hot or something like that. So that's my primary suspect. I'm just going to measure the resistance here on this Pincushion. This is the Sam's photo fax, by the way, for this particular TV. So this is going to be really helpful. But that's telling me that this should be a, if my eyes are correct here, 20 kilo ohm pot there. So we'll make sure that that's 20 kilo ohm, or it's reading 20 kilo, and then we'll take a look at this capacitor and see if it's leaking or out of spec. There's also a 10 microfarad electrolytic right here. So that one could be bad as well. And maybe it's causing this ground connection not to be connected properly, but we'll take a look at that too. But I think we're going to start with this one up here. All right, well, I ended up pulling that 10 microfarad capacitor first, which didn't think was the problem. But yeah, 10 microfarads rated at 160 volts. And I've got my meter set for capacitance. It's a little hard to do with these gloves. I suppose I could take the gloves off right now for this, but let's just go ahead and see what this capacitor comes back as. 13.63 microfarads. So yeah, I didn't think this was the problem. It's not the problem. So we'll put this back in. Now I've got to find that other 4.7 one though. All right, well, I pulled that other capacitor out, that 4.7 capacitor. It looks okay from the top, but notice anything missing here? And you notice anything on the bottom of the cap? So yeah, this one has blown its guts out, and the leg came off when I went to desolder it. The leg actually stayed in the board and the capacitor came off. Come on, focus. What's wrong with you today? So yeah, that certainly makes sense. If this was basically an open circuit right here where this capacitor was, moving that potentiometer for the Pincushion definitely would not have done anything. And whatever the default value is without this default voltage value, without this thing in place, probably 0 volts, was causing that Pincushion effect. So let's replace this and see if we can at least fix that problem. All right, I've replaced that cap. Got this thing plugged in. Let's see if it's any better. Uh-oh. Sounded kind of like I tripped something. And you can see the That's not good. Ooh. Yeah, that's not good at all. So something... Ooh, I'm smelling smoke. So that's going off. So something else is going on now. I'll have to check my work and see what I did. Dang it. All right, I apologize in advance for going handheld here, folks, but I just wanted to take you through my troubleshooting process so far. Since it seems to be a vertical problem, I started by looking at the deflection yoke, which, according to Sam's, should be around 91 ohms. And luckily, it does have the color of the wires here as well, which seemed to work out in my case. There's a green wire, over here, green wire that comes through and goes to the deflection yoke for vertical on this side. And then over here, there's a white green. So that made it easier to find and measure what the actual resistance is of the vertical on the deflection yoke. And it turns out that it is actually around 90. So that's good. So there, at least I know that the deflection yoke is working and the windings are okay. So then I started working my way back along the vertical path here on the schematic, and there's a pair of transistors here. And the first thing I wanted to do was just test the voltages. And when I tested the voltages, I got basically almost no voltage at all across those two power transistors. There's those two transistors right there. You can see them there, 1 and 2, and they're attached to this heatsink. And then those wires go kind of through the set here and come back to the horizontal and vertical driver board, or whatever they call this. But that's basically what's going on here. All the horizontal and vertical signals are being derived or going through this board here. So once I had that, I was just looking here and kind of testing things out. And I noticed that we should be getting 109 volts on this path here, and it was connected to this red wire. So I said, I'll just start with the red wire. And so I started looking for this resistor here, R566. All right, so this resistor right up here is blown out, and that is R566, the one that was on that sheet. And if you look in, I don't know if this will let me zoom in anymore. That's as far as I can zoom in, but hopefully you can see right down here, this one, which is R556, is also cracked. And I took the measurements of that one, and that one is also bad. So these resistors, this one and this one, are definitely going to have to be replaced. The question is, what is causing those resistors to blow? Are they just old resistors that, decided to go all of a sudden? Or is there something else that's causing those to get more voltage than they should, or more current than they should, or whatever, and it's causing them to crack and blow up?
2 weeks later.
All right, well, it has been a while. I had to stop filming this particular episode because I had some health issues, and I'll talk more about that. I don't know if you've seen my posts online, but I'll give an update on that in my next main channel video. For now, just know that it's very hard for me to focus. Depth perception is a big issue right now, but I'm going to try to finish this thing up anyway, as much as I can now that I am somewhat recovered. And yeah, so let's not focus on that right now. Focus, get it? Anyway, let me show you what I did. Well, I took out this resistor and I took out the other one, which I think I talked about. It's been so long, I don't remember. I think I talked about those just before the break there. And I tested this one out. It is completely open. So this thing has cracked right down the middle, and there's no conductivity, which is at least one reason why this set is not working. Now, this happens to be a 27 ohm resistor, and I dug around. I actually found these down at the Makerspace, where we have a lot of donated stuff. I found some 27 ohm resistors. This one, as you can see, the color isn't this beige color or a brown color, which you would expect. It's seems like kind of a greenish brown color or something. I think this might have been a fireproof resistor, which is why the color is a little bit different. And I could just put one of these in, since this seems to be a 1/4 watt resistor. But what I was hoping to do was put something in with a little bit more higher wattage rating. And so what I did was I created a 27 ohm. I didn't have a 27 ohm half watt resistor. So what I did was I hooked two resistors up in parallel. This is a 51 ohm and a 56 ohm. And when you do that, there's parallel resistor calculators online you can use. But basically when you do that, it's going to distribute the load between those two resistors, and it's going to deliver 27 ohms. In fact, I measured this resistor just a minute ago, now that it's all put together, and it does measure 26.9 ohms. So I can put this in and raise the wattage rating by virtue of using two resistors. I don't want to do it too much, but I would like to see if there's something else causing this resistor to blow. Maybe I can get this to last long enough that I can take some measurements and see what could possibly be causing this to blow. I also took a look at the big transistors here on the back. They don't seem to be shorted, although there are other transistors. I think the oscillator transistor and maybe the driver transistor. I didn't check those yet, but that'll probably be the next thing that I check if this resistor blows up and burns up on us after I get this thing up and running. So I'm going to put this in, and I'm going to put in that other resistor. I can't remember what the wattage was. It's in here somewhere, but I did find a half watt, the exact resistor I need. I think it was like 15K or something like that I need for that other one that was all cracked. So I'll replace those two, and then we'll see what happens. Okay, so I got those resistors in there, and boy, when you're down to one eye, depth perception is a real issue. But with the help of my phone, by being able to kind of look in here and see what's going on, I think I was able to get everything reinstalled, those two resistors. Complicating the issue is these wires. It's nice that I can, bend this board around and take a look at it and measure things easily, but trying to solder in between all these wires without taking them all off the board is a heck of a job, especially, like I said, when you're only using one eye. So, yeah, I'm going to have to double check or triple check all of this stuff, but I think I got them in there. Now, when I replaced those resistors, I smelled that magical, awful smell of leaky capacitors. So there are a few capacitors, basically 5 or 6 capacitors in this area surrounding where I replaced those resistors. So I think I better just go ahead and pull each of those out and see if any of them are bad, because it sure does smell like one of them is leaking, and one or more of them is leaking. And yeah, capacitor could definitely cause this problem of something overheating on one side or other of all these transistors that are in here. So that will be my next task. How many hours will it take because of my what's going on? I don't know. Okay, I went back through the schematic and took a look at the caps that could be in the path of the vertical signal here. And there were a couple of caps, more than 2 actually, that could, if either they had shorted or gone open, cause a problem. And so since we know that the horizontal is working, or appears to be working anyway, I went ahead and just focused on the ones that could affect the vertical signal. And what I found was there was one more cap that when I pulled out and tested was bad, and it was this 2.2 microfarad cap, or at least it was supposed to be 2.2 microfarad. And when I pulled it out and gave it the old sniff test, sure enough, it was bad. So I guess that's a good lesson. I mean, I always suspect the larger, higher voltage caps on these things to go bad first, or perhaps ones that are close to something that's getting hot. But in this case, neither of those were true about this particular cap, and yet it had leaked. And we can even test the capacitance anyway here with the meter. And when we do that, you can see it's nowhere near 2.2 microfarad anymore, right? It's down in the picofarad range at this point. So yeah, this was a bad cap, and that certainly could have caused the problem. Now, it doesn't necessarily explain to me that when the pincushion part of the circuit wasn't working, why we got a decent signal. And then when I fixed the pincushion, we didn't get a good signal, but I'm guessing it just has to do with the fact that when we fixed the pincushion, that maybe led to the resistors blowing, and this was just an added problem that just didn't get realized until we connected that part of the circuit. So I don't know. I don't know why that is, but I went ahead and changed that. And I also changed the other one. It was actually testing fine. It's a 4.7 microfarad, but I went ahead just since I was in there and I have tons of these. It's not like those larger caps I don't have as many on hand. I went ahead and changed that one too. So I think we're ready to test this. Got the new resistors in there, replaced a couple of bad caps. Hopefully the pincushion is working. So what I've done is I've got this board kind of tilted out here because that's where we were seeing the problems. I've got another camera turned on behind that's focused on that board so I can see, for example, if those resistors fry themselves out right away or what if there's anything interesting visually that happens on that board when we turn this on. One of the things I don't like, it's just a fact of life, is that when you turn this thing on, it takes a while for the tube itself, assuming everything is working, to warm up. So we're not going to see a good picture for a minute, but that could be enough time while the picture is warming up before we can see anything. That may be enough time to burn components out on the board. So I've got that extra camera set up, and if something happens, we'll go ahead and splice that video into this one. All right, so the set is plugged in. Let's turn it on and see if something blows up or not. Here we go. Okay, that high voltage sounded better than before. Let's see if we get a picture. Come on, you can do it. We do get a rolling picture, I believe. Let me see if I can fix the rolling. There we go. Still, the color looks bad, but we've got vertical back, folks. We've got vertical back. Yay! Okay, there's more to do here, but at least we're making progress. And you'll notice it looks like I need to fix some of this. We've got some rollover, or perhaps this is just the bottom of the screen here. Let's see if we can move this vertical positioning back to where it's supposed to be. All of the controls are messed up because I was cleaning them with deoxit and doing all kinds of stuff in the interim while I was trying to fix the vertical problem. So all of the controls are messed up. You'll also notice, though, pincushion looks a lot better. It's actually a little bit more blue. Okay, vertical size is working, but we're going to have to fix vertical centering. And unfortunately, that's not on a control. So that's going to be a resistor probably that I need to fix. But okay, we'll work on that when we get there. But this is working a lot better. Vertical linearity is now working. What about the tilt circuit? I don't know what the tilt circuit does, but that doesn't seem to do anything. Pincushion should be working. Yep. There you can see pincushion. That pot's still a little flaky, but you can see it's coming in and out there when I adjust that pot. So we'll get that lined up. Horizontal frequency. Yep. There we go. We can move that over a little bit so it's centered. So it's really just, I think, the vertical centering that is the problem here. Okay, like I said, this vertical centering does not have a pot on it. It's just using discrete resistors and apparently a jumper scenario. Now, there's nothing about this in the Sam's photo facts that I can find in terms of what these jumpers actually do, but I'll put a picture up of this so you can see it. There's a jumper over here right under vertical center. So this resistor here, my eyes can't really read it right now. I think it might be 562. But this resistor right here, it doesn't really matter what's in here because this jumper is on here, and apparently that was done at the factory, we're assuming. And, you know, if I measure there, of course, it's just going to be a dead short because that jumper is connecting those areas where that resistor is. So regardless of whether that resistor is working or not, it doesn't matter because that jumper is there and it's shorting the path. And then there's two other jumpers on the board. One for, I think it's R564 and another one for R565. The one for 564 is not connected. So that is not playing a part here in what is currently going on with the TV, but we can measure it anyway. And that one is measuring 15K, which is exactly what the schematic says it should be. But then we have this R565, which the jumper is there. So this resistor is in play. And if we measure that, it is measuring nothing because my meter just turned off. All right. Okay. So if we measure R565, we get about 9K, 9 and change. And so this is supposed to be 12K. So that could be part of the problem. I'm going to take the resistor out and measure it out of the circuit just to be sure. And assuming that it is bad, I will replace it with a 12K resistor if I can find one. Okay, I've got this resistor out of circuit. Woo! Hang on there, little buddy. Let's see what it measures. If I can get my probes on this without it going all over the place. Okay, there we go. Yep. Wow, okay. 12K, right on the money, pretty much. So, okay, so that's just was measuring weirdly in circuit. Out of circuit, it measures fine. And it doesn't have any burn marks or anything on it. It doesn't appear to be in bad shape. It's measuring correctly, so I'm just going to put this one back in. That is not the problem with what we're seeing on vertical center. All right, well, I did end up replacing a few more caps on here. Some were marginal, and I went ahead and replaced them because I knew I already had a couple of leaking caps already. So if I had the cap in question, I went ahead and replaced it. Others were bad. I did find one other one that was supposed to be, I think, a 22 microfarad, and it was reading like 68 microfarad. That probably wouldn't have hurt anything too much, but maybe it would have caused some noise problems or something. I don't know. So anyway, I did replace a few more caps in here, so let's turn it on and see what we've got now. Here we go, coming up. It's starting to warm up a little bit. It does take a little bit to warm up. So I'm not seeing what I thought. There was a bright line down here before, and I'm not seeing that anymore. Now this is just look like it's either getting cut off or that's just the bottom of the screen. And for some reason on this tube, it's not going all the way down to the bottom. I don't know. I don't think there's anything else left for me to replace except for the oscillator, and I don't think it's an oscillator problem, but if anybody has worked on these sets in the past and knows whether, this is just normal or whether there's something else I should look at that's causing this cutoff, let me know. I would still use it like this, assuming, of course, we can get the color fixed on this thing and back in tune. And that's what I'm going to work on next. Well, actually, look at this. I started adjusting the picture control, and it appears there's either a bad connection. It's acting like a bad connection up there. And that's when I wiggle it around, that's causing the color to come in and out. So it might be a bad pot, or it might be a bad wire connected over there. Okay, I am back after doing some investigation. Turns out that the picture control was a dual pot. And when I first did my first round of cleaning with the Oxit, I only got one of the picture pots. So now I got both of the picture pots, the dual pot, both of them. And so now I think that's what was causing that color problem that we were seeing. And I also needed a replacement knob because I got sick of switching this one back and forth between the power and the picture. So I went into Fusion 360 and printed this. Not sure you're going to be able to see it very well, but it is a little knob that should fit this thing. Let's see if it fits. This was my first print, and look at that. It goes right on. So yeah, there we go. That actually works really well. So I'm not going to leave this on here. My guess is I will see another one of these sets probably completely busted, but maybe it'll have good knobs and I can steal one in the future sometime when I'm at eWaste. So now the problem is that even though this picture the picture control isn't creating funky colors anymore, it still appears as though blue is missing. I can go on the tint, I can go all the way to green and get a nice bright green, and I can go all the way to red and we get kind of a pinkish red. Maybe I'll have to adjust that too. But in the middle here where it should be blue, yeah, it kind of goes almost right to green or red. There's almost nothing in the middle here. So I think I'm about where blue should be. So I am going to go ahead and use another tool that I made. So I don't have any non-conductive adjustment tools that are long enough to reach down to where the drives are for these colors. I can get to the background colors because those are nice and accessible right on the back of the set. But the actual drives, which I need to adjust here, are actually on the board and they go right down past the yoke there. That's not necessarily someplace where I want to get in with a small metal screwdriver. So what I did was I took this chopstick and a Dremel tool and I created a little tool that hopefully will be rigid enough. It certainly seems like it is, and long enough that I can get in there and adjust this safely. That's why I've got my gloves on as well, just in case something slips or whatever. I think I've got it in there. Let's see. Oh yeah, something's happening. Definitely it's getting more blue. I don't want to break this thing. I think that's as blue as it's going to get. Oh, and I did break it. I broke it off in there. Well, I think the pot is turned up all the way on the drive, so the only other thing that I could do is perhaps it could be a bad capacitor on that main board. I did try taking the main board off. You can take it off, but it's not easy to do, and really don't want to put that much more time into this if I can help it, at least not today. I might come back and see if I can fix some things like this cutoff here, whatever's going on there, and maybe the color. But let me bring some colors up on the Commodore 64 and we'll see what they look like. All right, so I've gone ahead and printed out some text on the screen in various colors. Black is up here. This is supposed to be white, although it's coming out a little bit yellow. And then we've got red, cyan, I believe this is magenta and green. So yeah, there's some colors. So we are getting actually decent colors out of this thing. The screen is flickering a little bit, and I don't know whether that's because we've got some, it could be down. I switched over to S-Video out of the Commodore 64 into the RF modulator. So the RF modulator could be picking up some interference. It might not be putting out a good signal, but S-Video has kind of cleaned things up a little bit. And again, we're getting, I think, pretty decent colors. So I'm going to go ahead and put the case back on this thing, and then I think we'll call this done for now. Like I said, I may need to go back in here later, change some more caps when I have some more time, probably when I am in better health and can see things better. But I think this is a pretty good result for now. All right, well, I think we're ready for a test with something other than a Commodore 64. So I got out my Sony professional VCR here, SJS VHS player, but it plays regular VHS as well, of course. I've got this all cleaned up. It looks really nice, and everything came out wonderfully, actually. The only thing I had to do, you can see here a little crinkle. There's this metal foil that goes around, and the tape that was under this, holding this down, had come out, and it snagged and bent a little bit in here. I can work on that a little bit more and see if I can get that all finished up, but it's pretty close, and it's down. It's stuck down with some double stick tape now, so it shouldn't come up again. Got the antennas there. Everything's looking great. So let's go ahead and turn on this Sony TV from the 70s with this Sony SVHS player from the 90s and play a little E.T., shall we? Now, I won't be able to play very long snippets of this because obviously it'll do a copyright match, but it'll give us a good idea of what this would look like with a VHS tape, at least, or with a regular signal coming into the TV other than the Commodore 64. I'm really curious to see if that black bar is still there at the bottom of the screen. All right, here we go. Now, of course, this is a dark part of the movie, but that looks pretty good to me. And I don't think I'm seeing the dark bar down here on the bottom, so I think that may have been an artifact of the RF modulator. Okay, now here's an outdoor scene. This is the infamous trick-or-treating scene. Hopefully you guys had a good Halloween and you did your own trick-or-treating. Maybe dressed up like this, but I love how they worked in Yoda, and he thinks that Yoda is related to him. Anyway, so yeah, I think this actually looks really good, except for this bar. If you have any ideas on how to fix that little bar at the bottom, maybe I have to actually adjust the convergence on the yoke itself in order to adjust that. Maybe it slipped out somehow. I don't know. But yeah, I think this set is actually coming along really, really nicely. I hope you enjoyed the repair process, and let me know if you have any ideas for this set. I feel very much redeemed in my fixing of this set because that other set that I had actually had a blown flyback, and I wish I could have fixed it, but there was just no way to do it. Now I feel very much redeemed in my efforts. This one went, at least according to plan, as much as it could. this repair is actually how I thought the other repair would go, with some blown capacitors and resistors and troubleshooting, looking at schematics and things like that. So really happy with how this ended up. If you want to see that original video where I actually modded that TV, or if you want to see the video where I tried to repair that TV, I'll link both of those videos right over here on the side, and I'll see you in one of those videos next.
End of line.